Hi students, Professor Nugent here. In this video we are going to conclude Chapter 7 with an analysis of the test score dataset. We have identified our variable interest as the student-to-teacher ratio. We can think about the omitted causal effects that could result in omitted variable bias. We know that whether the students know English, outside learning opportunities, parental involvement, teacher quality, if, for example, teacher salary is correlated with district wealth, are all candidates of being omitted causal effects. There is a very long list here. We want to include those omitted causal effects if you can, or if you can't, include variables correlated with them that serve as the control variables. The control variables are effective if the conditional mean independence plausibly holds. That is, if the OLS residual is uncorrelated with the student-to-teacher ratio once the control variables are included. We do expect that the control variables will be correlated with the OLS residual, and that's what makes the control variables good control variables. This results in a base or benchmark model. Many of the omitted causal variables are hard to measure, so we need to find good control variables. These include PCTEL, the percent of students learning English, which is both a control variable and an omitted causal factor. And this also measures, or is a proxy for, district wealth. We also want to specify a range of plausible alternative models, which can include additional candidate variables. It isn't clear which of the income-related variables will best control for the many omitted causal factors, such as outside learning opportunities, so the alternative specifications include regressions with different income variables. The alternative specifications considered here are just a starting point and are not the final word. We will estimate the base model and the plausible alternative specifications, and we're going to focus on the magnitude of the coefficient on the student-to-teacher ratio in the base model and the plausible alternative specifications to see how different is that coefficient. If the coefficient is different, then it's going to be hard to say that we have identified that population beta 1, because we have different size coefficients in different relationships. So let's look at the data. It's important to look at the data before you estimate any relationships. We're looking at scatter plots of test scores versus 3 student characteristics. In A, we have test score on the y-axis and percent of English learners on the x-axis. In B, we have test score on the y-axis and percent eligible for subsidized lunch on the x-axis. In C, we have test score on the y-axis and percentage qualifying for income assistance on the x-axis. And you can see that there is an inverse relationship for each of these comparisons. And interesting how that there is a very linear and tight relationship between test score and percent eligible for subsidized lunch. Alright, so we have a number of regressions and we want to report them. The text suggests that it is awkward and difficult to read regressions written out in equation form, so it is instead conventional to report them in a table. Now, it is not only my opinion, but I have been advised elsewhere that it is also important to include the regressions written out in equation form. Okay, so we want to include the equation 2. We may not include the estimates the OLS estimates and the standard errors and all of this data that results from the regression. But before we run the regressions, we may want to include the equation that we are estimating. And for those of us who are mathematically oriented, which will represent the majority of the audience of the paper reading this econometric analysis, an equation is important to include. It is, however, imperative that a table of regression results includes the estimated regression coefficients, standard errors, measures of fit, number of observations, relevant F statistics, and other pertinent information, such as confidence intervals for the causal effective interest. In a table, in a report, this should be a clean and easy to follow table. Other things that are included, pertinent information, such as variable names. Variable names, I've seen tables that don't include variable names, that are difficult to interpret. So this should be an easy to follow table, clean. Here is a table that's a good example. You have the variable of interest. It is relevant the way that you order your regressors. On the top, you have your variable of interest. You have the coefficient estimate, the standard error, the confidence interval, and then you include your control variables for the alternative regressions, right? We have regression 1, 2, 3, 4, and 5. We include percentage of English learners in 2, 3, 4, and 5, percentage eligible for subsidized lunch in 3 and 5, percentage qualifying for income assistance in 4 and 5. And so what do we see? That once we control for outside learning opportunities, the coefficient on the student-to-teacher ratio is somewhere between -1 and -1.31. So we have a small range of estimates with using varying control variables. So we can be pretty confident that we have identified the range of causal effects here. We have reported the standard error of the regression, the adjusted R-squared, and the sample size, and a brief summary or description of what was done here. So this is a great table, and I will show you in this data tutorial how to use data to produce a table like this. In summary, multiple regression allows you to estimate the effect on y of a change in x1 holding other included variables constant. If you can measure a variable, you can avoid omitted variable bias from that variable by including it. If you can't measure the omitted variable, you still might be able to control for its effect by including a control variable. There is no simple recipe for deciding which variables belong in a regression. You must exercise judgment, and one approach is to specify a base model relying on a priori reasoning. So a priori means beforehand, and then explore the sensitivity of the key estimates in the alternative specifications. If the coefficient on the variable of interest does not change very much from one specification to the next, then you have pretty good evidence that you have identified the magnitude of the causal effect.